So we will continue the discussion regarding the sample IoT exam paper. So in the last class, as I remember, we discussed up until the first question. So in today's class, we have to resume with the second question. So if you have any questions regarding this, you can let me know, and I will answer your questions. So the sample IoT exam paper is available in the LMS. So you can download it and you can refer the questions. So the second question is regarding a company operating a fleet of vehicles. So in this question, you are asked to design a computing solution to this application. So in our class that are used in IoT can be divided into three types: edge computing for computing and cloud computing. Okay, so what is the main difference between these three types of computing? What is the main difference? Okay, so there's only one student who's attending this class. So can you please let me know if you know the answer? Okay. So I will try to continue with the questions in the exam paper. So you are asked, you are an engineer at a company that operates a large fleet of vehicles equipped with IoT sensors. These sensors are used to track location and monitor fuel consumption, etc. The company's goal is to optimize its operations by using potential IoT and computing technologies. You're requested to select and design a specific type of computing solution for this application. So choose a specific application that requires computing capabilities in this scenario. So, we are talking about an IoT network that is handling a fleet of vehicles, a group of vehicles that are equipped with IoT sensors. Let's take this scenario and let's try to visualize this scenario. So we have a set of vehicles which are equipped with some sensors. Okay, so these sensors will take some measurements regarding it's one of its parameters like it could be the location, it could be the fuel consumption, it could be speed. Okay, so likewise, the sensors in that vehicle can make measurements regarding certain parameters. So each of the vehicles have, let's assume that each of the vehicles have uh, the sensors needed to measure a certain parameter. Okay, so let's assume that all the vehicles are going to measure a certain parameter while they are moving in the environment. So these vehicles, let's assume, are connected to a certain access point. Let's say they are connected wirelessly to a certain base station, right? So base station, right? Base station. So 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 they will be using a certain technology to connect to the base station. It could be cellular technology, right? You know, we can use 4G, 5G cellular technologies, and we can connect with the base station, and after that we can connect with the destination device using the cellular technologies. So let's assume that the devices are connected to the base station nearest to them, and they are going to they are forming an IoT network where they are sending data related to their status uh, with regard to for example, their location. Let's say they are sending their data with regard to their location. So they are sending their location data. So we can also narrow it further. Let's say they are sending their GPS location data. So if each of these vehicles are sending that data to this base station, what is the process that we need to follow to process this data that is collected from these vehicles, and how can we provide a useful output regarding this group of vehicles? What is the useful information we can give back to them? So that is what we need to think once we try to address this question. Okay, so you are requested to design a computing solution for this application. You are requested to design an IoT network, IoT system that uses a certain computing solution. Okay, so in this question, you need to design an IoT system that incorporates the one of the computing technologies. Okay, so you need to design an IoT system. Okay, gives that gives a useful that gives useful information to the customers, formation to the customers who are connected to the network, that gives useful information to the customers who are connected to this network and who's using some service. Okay, so let's assume the customers want to know their location their location they need let's assume that this application that we are going to consider is location tracking of the vehicles. Okay, so let's assume that this application is under the control of the vehicle owners. Okay, so let's assume, for example, like companies like PickMe, Uber, that provide taxi services. Okay, so these companies want to know the location of their vehicles, want to know where their vehicles are. So they need that data in real time, right? So they need that data in real time. So they want to know as soon as possible the location of their vehicles. So they want to know at which location a certain vehicle is under their company. Okay, so in order to get that data, they can install GPS sensors in each of the vehicles, and by using the data that is collected at their cloud servers or fog servers or edge servers, they can take out the information they want, and they can make some analysis on the data. So based on these their requirement, we need to propose the best way to compute best way to analyze the data by using a certain type of computing solution. Okay, so I hope it is clear to you. If it is not clear, please let me know. So what we are trying to do is we are trying to collect data at a certain server in the network, and give useful information to the vehicle owners like Pygmy, Uber, etc. Okay, so these companies, they want to monitor the vehicles that are connected to the network, right? So in order for them to monitor the vehicles effectively, they need to collect the data regarding the location of the vehicles. The data that is collected regarding the location of the vehicles must be stored somewhere, right? So the data that we are collecting is large in volume, right? We have large volumes of data, right? We have large volumes of data. So therefore, we cannot save this data in local devices. We need to have a specific location to store the data, right? We need a specific location to store the data, and we need a specific location to process the data, right? So we can do both the storage and the processing of the data at one location, right? So if we have enough storage at the location we are, that if we have enough storage at the location that we are trying to send the data, then we can process the data also there with the resources available. So what we are trying to do is we are trying to collect and we are trying to store the data at a certain location in the network. So we need a specific location to store the data and manage the data and process the data. So in order to do that, we need to decide which location we need to allocate for this purpose. Okay, so we need to actually store the data, process the data, manage the data. So we need to decide like which location is the most suitable location to do this work, right? We need to decide at which location we need to keep the data stored, and where we are going to process the data. So based on our application, we need to decide the best type of computing that is required, that is suitable for our application, right? So anyway, as the first question, in the first question, what I'm asking is that you need to choose a specific application that requires computing capabilities in this scenario. Okay, so you need to choose a specific application that will require computing. Okay, so right, so you need to propose a certain application that is suitable for this scenario. Okay, that we are considering, and you need to propose that application, right? So that application needs to be an application where we are collecting data from the vehicles. Okay, so that application needs to be an application that collects lot data from the vehicles. Okay, so we can propose different applications for this scenario, right? So right, so the example scenarios that we can propose are like example applications that we can propose are like location tracking is one example that we can propose. right? Another application that we can propose is the fuel monitoring, fuel monitoring, fuel monitoring of the vehicles, fuel monitoring of the vehicles, fuel consumption monitoring, let's say fuel consumption monitoring, okay? Fuel consumption monitoring, okay? Right? Right? So in the first question, I'm asking in what are the applications of this kind of a network of connected network of vehicles? What are the applications of this kind of a connected network of vehicles? Right? What are the applications? What are the scenarios where we can use such a network of vehicles? Okay. So one of the applications of such a network of vehicles is location tracking of the vehicles, right? We can track the location of the vehicles by collecting data from the vehicle sensors. So we can track the location of each of the vehicles uh, from a remote location, right? So if we want to know if one of the vehicles is missing or if some vehicle is not functioning properly, then we can monitor that using this location tracking application. And the second thing is fuel consumption monitoring, right? So that also we need to know, right? So if we can monitor the fuel consumption in a vehicle using some sensor, then we can send that data to the IoT network, where the centralized server that collects that data will be able to see the fuel consumption of the vehicles. So by monitoring each of the vehicle's fuel consumption, the controllers of the IoT network can decide like which vehicle needs the fuel most, which vehicle needs to be fueled, and so on. Uh, so that is another type of application that we can propose, that we can apply for this scenario. And then we can also do predictive maintenance for this scenario. So predictive maintenance means we are trying to predict the time at which the maintenance need to happen on this network, on these vehicles that are connected to this network. So the vehicles need to be maintained after a certain time once their condition is deteriorating. So if we have the necessary sensors installed in the vehicles, then we can collect the necessary data from the sensors, and by processing that data, we can maintained or set at a certain time. So that prediction can be done by collecting the data from the vehicles using this IoT network. And another thing we can do is like we can monitor the speed of the vehicles, speed monitoring or speed tracking of the vehicles, right? This is also another application that we can use in this IoT network, because this is also important. The reason in science we have to face proper one. So in order and keep the vehicle speed under control, we can do speed tracking of the vehicles, and we can remotely monitor the speed of the vehicles at a remote location, and we can do necessary steps. We can take necessary steps to keep the vehicle speed under the certain threshold, and ensure the quality of the driving of the vehicles in the network. So these are some of the example applications that you can propose for this IoT network of vehicles, right? So the applications that you can suggest, right, are these kind of applications. So these are 4 examples of the applications. You can propose more applications that are suitable. right? So this question ask you to choose a specific application that requires computing capabilities. So you need to choose a specific application like this, right? Like 1, 2, 3, 4 applications. You have to select one application, and then you need to select that application to answer the next questions. So the second question is about evaluating the possibility of using cloud, edge, and fog computing for this application. Um, and it also asks you to discuss the advantage of each approach. Okay, so the next question is uh, you evaluating the possibility of using the cloud, edge, or for computing for this application, right? So you are asked to evaluate uh, whether we can use cloud computing, edge computing, or fog computing, right? So you are asked to evaluate or just study whether whether it's possible to use these three types of computing, and what is the best computing method that we can use for this application. So let's assume that we are choosing the application location tracking for this scenario. So if we are using location tracking application, we will uh, right? We need to build the next answers to the second, third, fourth, and fifth questions. I think there are 5 parts to this question. So the rest of the questions that you are having after the first part must also be answered after considering the application, the specific application that you are considering for this scenario. So the application you will be considering is the location tracking application. So um, so you need to keep that also in your mind, right? So once you're answering this question, right, you need to evaluate the possibility of using cloud, edge, and fog computing in this application. So edge computing, fog computing, cloud computing are basically the main type of computing technologies that we can use in an IoT network, right? So in this question, basically we are asking like what is the best or what are the advantages of these types of computing, right? So once we are talking about the advantages of these type of computing approaches, right? So what is the main advantage of edge computing? Can you answer? Yeah, low latency, right? So low latency is a advantage in the edge computing, right? So uh, so uh, because of this, we can get real-time updates regarding the application, right? So we can get real-time updates regarding the environment using edge computing, right? So the amount of time that we uh, we take to transmit the data from the sensor locations up to the computing location is the least, right? So in edge computing, we have a server which is connected to the access point, which is directly connected to the sensor nodes, right? Also, edge computing can happen both at the access point server or at the sensor node itself, right? So at the sensor node also edge computing can happen. So edge computing can happen at the sensor level and also uh, at the access point level. So because of this, the amount of time that it takes for the data to enter the computing stage or the data to be processed is less. And the time it takes for the feedback to get feedback to be received is less. So once we consider the fog computing and cloud computing, the the latency is higher because the data needs to travel through multiple routers and switches to reach the fog server or the cloud server. Right. So because of that, once we consider fog computing, cloud computing, edge computing has low latency uh, in the low latency for communication, and therefore it can provide real-time updates regarding the uh, IoT environment. Apart from that, it also can handle large volumes of data. If right, it can handle large amounts of connectivity. Can handle large amounts of connectivity if if it has enough resources to connect to large number of devices, right? So it can handle large amount of devices connected to the uh, network, right? So it can handle large amount of devices connected to the network. So large amount of devices, so massive connectivity is possible, uh, right? So massive connectivity is possible, right? So massive connectivity is possible. That means a large number of devices can be connected to the edge computing server, and the server can manage large amounts of devices data, and it can store the data if it has the sufficient storage, and also it can process the data. However, it can manage the connectivity with the devices with a certain level of reliability, because the connection only needs to reach up to the edge server only, right? The connection does not need to go beyond the edge server. Therefore, the amount of the probability that the network can get lost and network connectivity can get lost is relatively low. So we can maintain massive connectivity. We can manage massive connectivity with edge computing with a certain amount of reliability, right? So since the devices are directly connected to the access point and the server there, the connectivity needs only to reach there, right? So the processing happens at the edge server, and the feedback are given back to the vehicles using the edge server, right? So when we consider about the fog computing and cloud computing, the data needs to travel through other routers and switches, and the data needs to reach those servers, right? So once we are having massive amounts of connections in our network, then sometimes if the network failures happen in intermediate locations uh, of the public network or public internet, or right, so in one of the links in the public internet, if we lose the connectivity, then the entire connected devices might not be able to connect with the destination server. So we might face some problems with the network connectivity with the fog server and the other cloud servers, cloud computing. So with the edge computing, right, we can maintain good connectivity with the devices if the devices are connected to the network through their communication modules in the first place. we can maintain the network connectivity with high reliability. So once we talk about the fog computing, so the data processing, what do you think about the, data processing ability once you compare with the edge computing? So once we talk about the edge server and edge computing, we normally assume that the amount of resources available at the edge server is lesser than the resources available at the fog server and the cloud server. So the resources means like the processing power, the storage, right? Those things we assume that it is not that um, sufficient once we compare with the fog computing and cloud computing. So if we take, so once we consider that aspects, we can say that the data processing ability is higher than edge computing, right? So in fog computing, the data processing ability is higher than edge computing, right? So therefore, we can maintain high processing done at the fog server, and therefore we can provide some useful information to the network users using fog computing, right? So this is also advantageous in situations where the cloud server is located at a very far location from the access point. So useful uh, when the cloud server is very far from the access point. Okay, so now so with that we have discussed about the advantages of the fog computing. So in fog computing, we can do higher data processing at the server uh, rather than the edge computing and the edge server. So in edge server, we assume that the resources are uh, limited, and therefore it is not able to do a high amount of data processing when compared to fog computing and cloud computing. Okay, so the fog computing is important in specific cases where the access point is and the cloud server, the distance between the access point and the cloud server is significantly high, such that the data communication latency will be higher if the data has to be transported from the access point to the cloud server all the time to get some update regarding the environment. So rather than sending all the data to the cloud server, we can send the data to the fog server, and we can get some data processing done there, and up to a certain level, and we can after that we can take some useful data from that processing. So once we consider cloud computing, what is the advantage of cloud computing when we consider about edge computing and fog computing? What is the advantage in cloud computing in comparison to edge computing and fog computing? Can you let me know? Okay, so as the time is going, I will explain. So the cloud computing has more resources uh, than for computing and edge computing to process the data. And it has more storage, it has more infrastructure to manage the data. So, like third-party cloud service providers, cloud service providers are able to provide the necessary uh, infrastructure, security, right? Security to the clients who are using the cloud service, right? So once that infrastructure security is provided, the and also it provides the necessary storage, it provides necessary processing resources, right? Once these resources are provided, the clients are able to use this infrastructure to process their data very fast and process them very reliably. So companies like Amazon, Netflix, YouTube are using these cloud servers to process their data with minimum latency and as quickly as possible, and give a good service to their clients. So the cloud computing is able to process the data, store the data, and manage the data very uh, very uh, very reliably using the high amount of resources that they have. So in cloud computing, we have high or very quality resources. We have high quality resources. We have high quality resources, uh, and therefore we are able to uh, get we are able to process the large amounts of data that we have in our IoT network. Okay, so we can process large volumes of data. We can process large volumes of data, and we can analyze the data. We can store and manage the data very reliably. So we can handle large volumes of data easily using cloud computing. So if the data is reaching the cloud servers reliably, then the rest of the process can be done very easily using cloud computing. So I hope it is clear to you. And with that, I will move on to the next question. So we have discussed about the advantages of the three types of computing methods. And now we are going to apply that knowledge into the application that we are considering in this scenario, right? So in the next question, I'm asking about uh, establishing a selection criteria to select the best computing method for this scenario. Okay, so right? So our application is location tracking, and based on the application that you select, you need to decide what kind of a performance criteria you need from this IoT network, right? What kind of performance you need uh, from this IoT network, right? So by performance, what I mean is we can consider several factors. We can consider factors like, I have given the factors in the question itself. We can consider factors such as data processing, storage, real-time updates, network connectivity, data privacy, cost, resource availability, etc. So based on those factors, we can create a criteria. We can create a set of criteria for our IoT network, right? So we can establish certain criteria for our IoT network, right? So with that, what I mean is that we can say, okay, for this from this IoT network, I need this kind of a performance, right? So I hope it is clear to you. If it is not clear, you can ask me, right? So uh, so so like from a certain IoT network, we expect some kind of output, right? So let's say now in here, pick me honors. Let's say it's pick me who's deploying this network, right? So the pygmy owners are telling, I need high data processing done at the network. I need high data processing done at the network such that the update can be given very fast with low latency, right? So I need very fast updates regarding the network. So I will say I need real-time updates from the network. I need real-time updates from the network. And I also will say that I need I need I need I need to implement this network with this network for to manage like large amounts of vehicles. So or else I can say I need to implement this network to cater about 50 vehicles or something, right? Not that large, but about 50 vehicles. I want to manage about 50 vehicles using this IoT network. I need to monitor 50 vehicles of 50 vehicles. And I need to store the data. I need to store the data, analyze the data, and have, yeah, I need to store the data, analyze the data, and manage the data, right? And then I will say I need to have less network connection losses. I need to have less network connection losses. So likewise, I can say I need these things. I can demand, right? These are the performance that I need from this network. So based on those demands that we specify for this network, we select the best computing technology for this application, right? So if we want to manage if you want to give real-time updates, right? Giving real-time updates is the um, uh, is our highest requirement, right? So we are going to make a selection criteria. So under that selection criteria, we can mention that the real-time updates, providing real-time updates is of high necessity. We need this. We need to provide this. So this is high priority. So we need to provide real-time updates. So that means we need to provide updates with low latency. Next, we want to give we want to have connectivity for about 50 vehicles, right? So connectivity for low number of vehicles, right? So low number of vehicles. So it's not a massive connectivity scenario. So we can say for low number of vehicles, about up to about 0 to 50 vehicles. Then we need to have low network connectivity losses. That means like network connectivity losses. That means like we are trying to reach the connection up to the point where we are storing the data. So once we are trying to reach that point, if we get some network losses, then we say that we say that we are losing the network connectivity, right? So if we want high network connectivity, then we need to ensure that the connection from our access point to the end device or the end destination is very secure. So for our application, we will say that we need high network connectivity, or we need good connectivity with the place where we are storing the data. And then we need high processing or kind of a medium data processing ability. Since we are only going to cater uh, 50 vehicles, our data processing ability should not be too high or too medium. We can maintain it at a low level, right? So likewise, we can define some parameters or criteria for our network, right? And the cost of implementation, we are trying to make it low, right? So every person wants to make the cost of implementation low, right? So we can we can say that we want to maintain the cost of implementation low, right? So with this criteria, now now we are going to decide which computing technology will suit this criteria that we have decided, right? So based on this criteria, we are going to decide which computing technology is best for us, right? So this is the criteria that we have defined. I will leave it as that, right? And we will move to the next question, right? So the next question is, based on your evaluation and selection criteria, choose the most appropriate computing solution for the application. Give reasons why it aligns with your objectives and requirements. Okay, so in this question, they're asking, like, based on the evaluation and the selection criteria that you have done in parts 2 and 3, choose the most appropriate computing solution for the application. Okay, so in the 2 and 3 parts, you have identified in the in the second part, you have identified the uh, 3 basic computing technologies, right? In the third part, you have identified what are your requirements in this application. So you have decided the criteria, and you have done a investigation evaluation regarding the computing technologies. So based on these knowledges, based on this knowledge, you're asked to select which type of computing is suitable for your application, right? So based on the criteria that we have selected, we need real-time updates. We need connectivity for about 50 vehicles. We need high network connectivity uh, between the access point and the end destination. We need data processing ability. A low level of data processing ability is enough, and the cost of implementation should be low. So based on all these criteria, I would suggest we need edge computing, right? We need edge computing, I would suggest, right? So then I'm asking why it aligns with your objectives and requirements, right? So my objective is to give real-time updates. My main objective is to give real-time update regarding the location of the vehicles. So in order to give that information, I need to use computing technology like edge computing or fog computing, right? Because I need to maintain the low latency output, right? I need to maintain this metric. So therefore, I suggest that we can use edge computing for this application, right? So main objective is having the real updates and updates regarding the location. Also, the requirements. My requirement is giving low latent feedback to our customers, and therefore that is the objectives and requirements of this application. So giving low latent feedback, right? So in order to do that, I'm suggesting that we can go ahead with the edge computing solution, right? So with that, I go to the next question where I have to draw uh, an IoT network indicating all the components that indicating the proposed architecture with the computing approach that we have proposed. So, right. So I'm going to erase this. Right. So we are asked to draw the proposed network architecture. Right. So I think this is the picture I have drawn earlier. So I can use the same picture. Right. So our computing solution is edge computing. So edge computing based IoT network architecture is what we are proposing. Right. So we are proposing basically not only a network, but also an IoT system, right? This system contains not only networking, but also collection of data, storing the data, managing the data, analyzing the data, and so on. So therefore, we will call this as IoT system. So our system will be edge computing based, and therefore our system will look like this. It will have vehicles like this, and the access point will be a base station. Access point will be a base station, and the connection from the base station will be given to a server which is placed near the base station in the control units. So we will be doing the processing at the edge server. So edge computing will happen at the edge server. Right? So edge server will be here. So the computing will happen here. Right? So once you are drawing this network architecture, you need to mention where the computing is done clearly, and you need to mention the access point, and you need to clearly maybe draw it and point it, and then you need to mention where the vehicles are and the sensors, where the vehicle sensors are, right? So those things you can mention very clearly in the network architecture. So as I said, we can do edge computing at the sensor node level as well. But in this architecture diagram, I will only draw the situation where we are doing the computing at the edge server near the access point, because I'm proposing this for the scenario where the company, the PICME company, is using that data. So if we are going to do the edge computing at the vehicle level, the PICME company might not be able to access that data which is available at the vehicle level. So since I want to pass that data to the remote location where the edge server is, I need to do the processing at the edge server, so which is placed near the access point. So the vehicles are the IoT devices, vehicles vehicles that have vehicles with the sensors. Vehicles with the sensors are the IoT devices, right? These devices are connected to the access point through 4G, 5G cellular technology, and you can consider this entire thing as your edge computing based IoT system. However, like since we are talking about Internet of Things, it's better to mention where the internet is, right? So the base station does not stay isolated like this. We have connectivity from the base station to the core network, and from there onwards to the internet. So let's try to draw the core network to which the base station is connected, right? So it is connected to the base station using a wired connection. So the base station is connected to the core network through wired connection, and basically using fiber cables. And then the core network is connected to the public internet, and the public internet allows you to access the internet and transmit your data into the internet. So this part also you can add to your network architecture, just to complete the diagram by indicating where the internet is and how we can access the internet if we want in our application, right? So this is the network architecture that you can propose for your system when you're answering this question, right? So this is my drawing. You can draw much more clearly and with more details. You need to label basically the IoT devices, the communication technology, access point, the network through which you are transmitting data. If you do not have such a network, you can end with the edge server. If you are going to go and use edge computing, fog computing and cloud computing, you need to necessarily draw the network through which you access those servers, right? So if you have fog computing, you will have the server here in an intermediate location between the cloud server and the access point. So we will take the cloud server is in a remote location, and the cloud server will be here. The fog server will be in an intermediate location between the cloud server and the edge server. So with that, I will end today's class. I hope you understood my content. So if you have any questions, please let me know. I will discuss them in the interactive classes.